constant term in the equation of the polynomial function is the y-intercept. But remember, this has to be no brackets, right? The moment there's brackets, it doesn't work out like that. Okay, so what you're going to do is you're not going to touch your calculator at this point. You will touch it in a little bit, but right now you're going to put down your calculator. You're not going to have it in your hand. If you have it in your hand, you're going to put it down. And you're going to match each graph to the correct polynomial function. And you don't have to justify your reasoning to me, but you have to justify to yourself why. So you're going to look at these three equations, and based on, for example, the constant at the back, that's your y-intercept. The leading coefficient tells you how it ends on the right arm. If it's a degree 3, so x cubed, you're going to get that little cubic looking function, right? The weird little sideways s. If it's an x squared, you're going to get a parabola. So you're going to get it concave up or concave down. And if it's linear, you're going to get a line. So that's at least going to narrow it down to 50-50. Okay, just even the fact that it's a square, a cube, or a linear. So you try it out, match them, don't talk to anyone, just try it. Okay, I'm going to do the x cubed ones first. So G or P are the x cubed ones. So that's going to either be 4 or 6, right? They both have y-intercepts of -2, so that doesn't narrow it down at all. But there is something that gives it away. Pardon? Yes, the leading coefficient. So g of x is negative, so that means it's down on the right. So this one's g. P of x has a positive 1, so it's up on the right. Then let's go to the squareds. How can I tell the difference between the squareds? The y-intercepts, because they both have positive leading coefficients, so they both end up positively on the right, so that didn't narrow it down. But this one has a y-intercept of 1, and so does this one. So this is k of x, and this is j of x, because -2. Then our linear lines. They're both leading coefficients negative, so they both go down. They both have y-intercepts of -3, so how could I tell them apart without putting in my calculator? Grade 10. If this was grade 10, how would you tell them apart? Slope. So I go from one point to another. So I'm going to go from here down to right 1. Or this one is down to 1, 2, 3, 4. Right 4. So down to right 1 would be q of x, right? And then down to right 4 is -1/2 as my slope, which is h of x. Okay? You try this one. These ones. Try these ones. Or these ones. So I would expand this one out. It's going to be x squared plus x plus 2x, which is plus 3x. And then times 1 times 2 is plus 2. And this one I would write as y equals -x plus 3, because I like starting off with the leading coefficient. Okay. So I'm going to do the cubic ones first. B and f are cubic. And 4 and 1 are cubic. So this is 1, 2, 3, 4, 5, 6. So both of them have y-intercepts at +4, so that didn't narrow it down at all. But this one has a +1 in front of it, so I need to look for the one that's right arm is going up. This right arrow is down, so it needs to have a negative leading coefficient. And this right arm is going up, so it needs to have a positive leading coefficient. So this one's going to go with 4. And this one's going to go with 1. Then I go to my squareds. I expanded this one out because when it's not in brackets, it's easier to tell your leading coefficient and your y-intercept. So they both have positive leading coefficients, so they're both up on the right. This one is a +2 as a y-intercept, so it's going to be this one, which is 3. and this one has a plus 4, positive 4. So this one is 2. The two linear equations both have plus 3 as their y-intercept, so that doesn't narrow it, so we're going to have to look at the slope. This one, you go down 1, right 1. So it's going to have a slope of 1 over 1. I mean negative 1 over 1, sorry, which is negative 1. This one you go down 1, 2, right 1. So this one's going to have a slope of negative 2 over 1, which is negative 2. This one has a slope of negative 1, which is this one, 5. This one has a slope of negative 2, which is this one, 6. So you should get 5, 2, 3, 1, 6, 4. We're going to flip past the next lesson because we'll come back to it in your notes. It's the x and y intercept lesson. We're going to flip past that one. Maybe. Like bad. So at time 0, they have nothing, no medication, no concentration in their blood. Susan has collected the following data and is attempting to express the concentration as a polynomial function. So at time 0, she has nothing, no concentration in her blood. At 1.5 hours, she has 26.9 concentration. So why wouldn't she just have maximum concentration like right off the bat? The moment she puts it in her mouth. Is that how any type of medication works? Like you put it in your mouth and instantly Tylenol works and you feel so much better, or Gravol, you're good. Yeah. No. It takes a while to break down and get concentrated in your blood. Then it reaches a maximum, and then after it reaches that maximum, the concentration reduces till you get back to nothing again, right? And then that's why Tylenol says every 4 to 6 hours take a new one, because by then it's really low concentration, you start again, right? Work through the whole concentration gradient. So at 1.5 hours, she has 26.9 milligrams per liter. Then at 3, 41.2 milligrams per liter, 4.5, 6. What's happening here? I go up to 47.8 and down to 46. Do you know how many people tell me it maxes out at 47.8? Is that a guarantee? Because on this table, it's the highest, so it must be the maximum. Does this table represent every time amount possible? No. So you can't just go to your table and pick off the highest value and say that's the maximum, which everyone does on the test. Don't do that. Don't be that person. That person. Okay. So we're going to learn how to punch this in our calculator. If we can't use our calculator, we're not going to know how it is. You want to put it there so you don't lose yourself? All right. So we need to know the steps. We need to know the steps, and some of the calculators are a little bit different in little steps, but for the most part, 90% of the steps are exactly the same. Okay? So this is what we're going to do. We need to come up with an equation. Your brain looking at this, no matter how long you stare at it, is not going to pop up a linear, quadratic, or cubic equation just in your head and then you write it down. It's not going to happen. Your calculator has to do it for you. So this is what you're going to do. If you look on here, it says, hey, enter data into lists. So that's what you're going to do first. How do you do that? Anything that's in a little box is a button. So you're going to press stat. Go to your calculator, and you're going to press stat. Stat, right here. It's below the delete button. Okay? You're going to press stat. And then you're going to press edit, because you want to edit the list. Now, please put your calculator down for 3 seconds so that you can pay attention to this and not be lost. So say I enter something in. So say I go 1, 2 hours, 3 hours, and then there's like 10, and these have to correlate together, right? So at 1 hour there's 10, and at 2 hours there's 20, and at 3 hours there's 30, and that's my data from this list, okay? And I'm like, oh, I want to enter new data, and then you're deleting the whole way up. That's not how you can clear the list. If you want to clear the list quickly, there's a clear list button. But what you can also do is you can go all the way up to list 2. Now think about this, because I have so many people delete their lists. If you delete your list, you're going to have to reset your calculator to come back. It's not like it's gone forever. But do I want to delete my list, or do I want to clear my list? I want to clear my list. If you press delete, enter, it deletes list 2, and I have to reset your calculator. You're going to have to if you're really a avid deleter. Okay, you're going to have to learn how to do it. So if you delete the list, it's not the end of the world. You can get it back. However, don't. I don't want to delete the list. I want to clear the list. So I go clear on this L2. I go clear, enter, and it clears the whole list. Go over here, clear, enter, and it clears my list. So if you have something in, clear your lists. Now, time is always list 1, because time is always X and concentration is Y. And I have always seen on the diploma that they give them X, Y. I hope they never ever do the flip, but that's the only way I've seen them. So you always have to have an X for a Y. So please stop for a second, put your calculator down so I know you're listening. In kindergarten, they make you hold your ears. Listening ears. Okay, so Evan's listening very closely. So what you could do is in the table, they might have like 5 hours like this, and then have the actual concentration blank. Okay? Paying attention? Got this? So this happens. Is there a Y value for that 5? Technically, yes. Did they give it to us? No. Every single time we input something into list 1 and list 2, we have to have an X and a Y that correlate together. Okay? Do we have it? No. They're probably, if this is how the list works, they're probably, the question on the actual diploma is probably at 5 hours, how much is the concentration? Okay? That's probably what they're going to ask you if they leave one blank. What are you going to do when you have one of these that are blank? Ignore it. Pretend it does not exist. If it doesn't have an X and a Y that go together, it does not go on your list. Okay? So if this was actually on the table, I'd be like, no, thank you. I'm not going to put that into my table because I don't have an X and a Y that flip. For those of you who put 0, so when it's blank, you guys put a 0 here. You are completely ruining your question. Because what you are saying by going into that list and putting 5 in list 1 and 0 in list 2 is you're saying at 5 hours that there's a concentration of 0 milligrams per liter. Is there? No. Will that completely destroy your equation? Yes. If your line was like this, it'll be like this. Then you have a point down here, and then it'll carry back on, which isn't true. It should be try and like draw a line. It's not going to happen. Okay? So the worst thing you could do is put the 5 and put a 0 because it's going to make it completely wrong. Okay? Because there really is, at 5 hours, there isn't 0 milligrams. And you can tell by this if there isn't going to be 0 milligrams. There's going to be some value. Right? So we completely ignore it. So go to your list 1 and list 2 and type them in. Make sure that 0 goes with, and then 0's right away, and then 1.5. So I just do all my X's at once. 0, 1.5, 1.5, 3, 4.5, 6, 7.5, 9. If you think on the test you're going to ask me over to give you all the steps on how to punch this into your calculator because you still don't know, I'm going to say, sorry, I can't help you. Because on the diploma, I literally can't be in the room. I cannot be in the room with you. Okay? So I can't help you here either. You need to know your stuff for your test. You need to know your steps. So you can't be like, Mrs. Lepp, I don't remember the steps. Can you tell me? And then you call me up for every single step and think I'm going to tell it to you. I can't, and I won't because I'm setting you up for failure for the diploma. Okay? You need to just learn them, which if you do all the work and you do all the homework, you will know the steps. So 0, 26.9, 41.2. Okay. If it errors you when you go to calculate something, sometimes your lists are lopsided. Like one list will have like this many and the other list will have the number down to here. You have to have the same amount of in list 1 as in list 2. Okay? Can't work that way. You can't leave it blank, which some people try and do. Okay? Now what I'm going to get you guys to do is go second stat plot. I'm just going to show this to you once. I don't like using plot. I like using the regression analysis, but we're going to show you this. So press enter. So you're going to press second window. Yep. Second window. Oh, second Y equals, sorry. It's, yeah. And hit enter. And then you're going to turn it on. And just press graph. Y equals So you're going to go second, stat plot, enter, and on. And you see here list 1, list 2 is your X and your Y's, right? So just, you're going to go second, stat plot, and just turn it on. Yeah, and then just go second mode if you want out of it. Whenever you're in a screen and you want out of it, just go second mode, because what's the word behind mode? Quit. You want to quit it. I want to quit this. I want to quit you. Yeah. So we press graph and people are freaking out. They're freaking out. They're like, Lepp, there's 1 point on this entire thing. That doesn't even make sense. Let's use our brain matter and think, why would 1 dot only be showing up? Look at our table of values. Look at our little table. 0, 0 is there. 1.5 and 26.9. Oh my goodness. My second Y value is 26.9. That's like way the heck up here. It ain't showing up because it's not on my screen, because my screen is too small for you to see the little points. So whenever you do regressions, you guys, you should be changing your window. I love regressions, and you will too, because windows are very easy to make when you have a regression. It gives you, it will, trust me. It gives you the X values and the Y values you need. So I'm going to go to my window, and my lowest X value is 0. My lowest X value will be 0. I can't do negative time, right? My highest X value right now is 9. I always like double it. So I'm going to make it be 18. Because they could ask me at 12 hours, what's the concentration, right? And if I only make it to 9, I can't answer the question. So I'm going to make this be 18. My X scale could be 1, 2, it doesn't matter. What's my minimum concentration I could possibly have? 0. I can't have negative concentration. It's not like it can rip extra out of my body. Okay, that's just weird and creepy. Okay, I don't have any extra of whatever this is that's in there. So 0. Some people try and tell me that is not the case. What's the largest value I have? 47.8. Could it be higher though, technically? It could be higher. So I'm going to make it be 55. If you made it be 50, you might be okay still too. I'm just going to do 55 because I like being a little bit higher just in case, you know, it might go up. Spike. I'm going to make my Y scale be 5 because then every little tick is 5. But if you leave it be 1, it will do nothing wrong to you. You're just going to have so many little tiny little lines that it's going to make it thick and you won't be able to see them. But you'll still be able to calculate everything. So if you left your Y scales and X scale at 1 all the time, it'll always be able to calculate it. You just can't literally see the ticks. Okay. So now let's press graph. Ah, there's more dots. Life is good. Life is good. Okay. What does this possibly look like it could be? Parabola. Looks like it could be, possibly. Yeah. I really want to turn. Okay, so I like stat plot in the fact that you can actually have like some idea of what the data looks like when it's drawn. However, if your stat plot is on, it will not let you calculate the equation. So that kind of is bad. So I'm just going to go and turn my stat plot off. So I'm going to go second stat plot. Once you look at the data, always go turn it back off if you want to. I rarely look at the data because this is what I'm going to show you what to do. So there's this thing called a regression equation, which is what we're finding. And then there's an R squared, which is the correlation coefficient, which will make sense in a second. So if I was looking at data on a graph like this, and I drew all the points, okay? And the points look like this. Okay? And I said, okay, I want you to come up with a linear equation that fits this data. Okay, and what your calculator would do is it would like take all the points and it would do all this lovely math, and it would come up with an equation like this, where Some of the points are above, equal number of points are above, equal number of points below, and you have the same amount kind of on the line. Sometimes you don't have any on the line. Now, do you think this line fits this data really, really well? No, it kind of averages it kind of nicely, but it fits it really well when a lot of the points sit on the line. Or if it's a quadratic, if a lot of the points sit on the quadratic, right? So there's a thing called the R-squared, it's the correlation coefficient. Your R-squared value, the closer it is to 1, the better your data fits it. So this one would probably be like 50%, so like 50% of the data, or 0.50, right? The lower the decimal, basically the worse this line or whatever equation it is fits the data, okay? So if I had something like this instead, and it did a line, okay? Which one would have a higher correlation coefficient, an R-squared value? This baby here, because more of the points fall on this line, right? So this would have a higher one, which would mean it would be closer to 0. Or closer to 0, closer to 1. 0 is not true. Okay, so how do we turn that lovely thing on? Every single time your calculator is reset, it goes away. What happens the very first step of your diploma? Your calculator is reset. Okay. So what we're going to do for every single test is we're going to reset our calculators, just in case you know you have something there on there that you shouldn't, but also to practice finding this spot. Okay? So we're going to follow along and we're going to write this down. And we're going to have phones away, and we're not going to be touching a phone. We're not going to be near a phone. The phone should repel off of you if it comes near you. It should like fly away. Okay? You're going to go second, mem, plus sign. Number 7, which is reset. Over to all memory. So, and then reset. I'll go through it again. Chill. Okay. So you're going to go second, once mine decides to. I love how it's clearing my calculator from my, like the one that's on my screen. It's taking this long. There's so much data on this calculator on the screen. It's craziness. Okay. Not for you for now. Yeah. Unless you press the sine, cos, tan button or the second sine, second cos, second tan button, radians or degrees, doesn't matter. So you're going to go second plus sign. I won't clear it, but second plus sign. Number 7. I know, but mine's frozen. And then you go over to all. All memory, hit enter, and then you go to reset, which is number 2. And it resets the whole thing. If on the diploma you don't remember how to reset it, that's the only thing that someone can do for you. So call someone over, they'll reset it for you. Okay? This is good. I'm glad it. Okay, I have to pull mine back up. I just have to take it off and put it back on. So we're going to go second, 0. The word behind that is catalog. It has all of the words in it. So if ever you were like, oh, I can't remember where to find the absolute value, you could go through this catalog, and it's the first one. It's alphabetical order. What you need to find is diagnostic on. You want to turn the diagnostics on. The diagnostics on will get you the R-squared. So we're going to go down. No, we're not. No, I just put my thing on. So you're going to go to diagnostic on. Okay. Get to diagnostic on and you hit enter. Everyone's like, I'm done. No, you're not. You're not done until it says done.
There's so many of these things. Oh, I found it.
So on your little sheet, your calculator cheat sheet that you're not going to get on the test, but you can study from, at the very top of it, I would put how. To turn diagnostic on, what I'm going to do is I'm going to go second, 0. Then I'm going to go all the way down to diagnostic on. Then I'm going to hit enter. And then it is going to say, what? Done. And then you know it's done. Diagnostic on you only need if it asks you what regression is best, which I've seen on tests before. Okay, so we have our data, correct? Now we want to figure out which regression fits it best, so we're going to pay attention. We're going to look at the back of our sheet. Yes, you have to put the list and everything back in. Enjoy. So, we're going to practice it. We're going to go stat, edit, 0, 1.5, 3, 4.5, 6, 7.5, 9. Yep. Because it needs to have that point that at 0, it's 0. Right? That means something. So if ever it doesn't let you calculate a regression, it's probably because your stat plot's on. So if you happen to want to look at it and you turned your stat plot on, you have to remember to turn it off. Okay? So right now your stat plot is off because whenever you reset your calculator, it turns everything back on. So we're going to go stat. If you look on your little sheet under D, it gives you the steps in how to get the regression equation. Here it says determine the regression equation, and it gives you little steps. Okay? So we're going to go stat, and then we want to calculate a regression. So we're going to go over to calc. Now, the only 3 we're going to use for this unit are 4, 5, and 6. 4 is linear, 5 is quadratic, 6 is cubic. Now, if you look down here, there's this linear backwards one. Don't touch it. There's ln reg, which we will do for logs, but none of that right now matters. The only thing for this test you're going to push is 4, 5, or 6. So we're going to press 4 for now and hit enter. And then we have to hit enter again. If you're a TI-83 and something pops up, or a TI-84, sorry, and something pops up, put your hand up. I'm going to help you specifically. And the rest of you, shh. So, this is what you got. Now, we're going to look up here. We look at the R squared. We don't care about the R. The R squared is the correlation coefficient. So 15% of the data fits this line. Is that a good equation? Not very good. So then we're going to go stat, calc, and we're going to try quadratic. Quadratic, 99.6% fits it. Is that good?
Yeah.
Let's try cubic, because it might be better. 99.6. Stat, calc. So cubic is the best. Now, from the stat plot, we really couldn't tell that, right? When we stat plotted it, we could tell that linear was not a good option because it made a curve. But we couldn't tell that quadratic was awesome, but cubic was even more awesome. Now, if on the test it says find the quadratic regression, you have to find the quadratic. Even if the cubic is better, you can't be like, no test, you're wrong. The cubic is better, and so I'm going to find it. No, you can't. If it says which of the following is the best, which regression best fits the data, then you'll do this and you'll pick linear, quadratic, cubic, whatever, right? Then you'll choose from there. But if it tells you have to find the quadratic regression, you have to find the quadratic regression. Okay? All right. So what I want you to do, we'll do all of this stuff in a second. I want you to move ahead to the next one. I just literally want you to type it into your calculator and find, for this example one, oh, that's the same one. Matt lied. Go ahead. So here, all I want you to do is go to this example right now, and I want you to tell me, is linear, quadratic, or cubic better? Okay? Try it out. Fill it in. Be a friend with someone if you want. Your A value would be 0.32090985886 x cubed plus, or actually minus, 6.368406767 x squared plus 45.901672225 x minus 44.2126624 blah, 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 right? That would be awful to have to write that all down, then go into your y equals and type it all out, right? So let's think about that. Let's think about that before we whine about all the steps I have to teach you and how to get it in easily, okay? You're going to say, that's not easy. This is way worse. If you had to write this all down and retype it into y equals, that would be way more awful. So what you're going to do, if you weren't taught the other way, this is what you're going to do. So you have your calculator, okay? If you look at E, it gives you the steps, okay? If you look at E, it gives you the steps. This is how you get into your y equals. So I have the very first one, right? This is mine is the first equation, not the equation you have, so it's going to be a little different, but still the same steps. You're going to go y equals, and you're going to clear out anything that's in there. Okay? Okay. Then you're going to do this. Yours is fine. Yeah. If you're someone who I taught with all those other little steps and you have it already in y equals, don't touch it. If you don't, though, you're going to go varse. And if you're someone who learns the other way, block your ears, do not listen to me, ignore me, do not learn the way I'm teaching you because it doesn't work. Go varse. Go number 5, statistics. It says on here. So it says, send regression equation to y equals by pressing y equals, E says send regression equation to y equals by pressing y equals. With the cursor in y1, do the following. Varse. Down to statistics, enter, over to equation, enter, and it's in. So you go varse, down to statistics, over to equation, and enter. The steps are in E. If I showed you the other way, then do it the other way. Don't ever do it this way. If it like pops up, it's way quicker. Varse, enter, 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 enter. Okay? Then you press. Oh, you're ready. You have to clear out your y equals. You had something in your y equals? You have to clear it out first. So, press graph. If you press graph, it probably doesn't show up. Or it does partially. Every single time you press graph, you guys, you have to first make sure there's nothing in your y equals. If you have something in your y equals, it'll error you. Your y equals has to be clear every single time. Yeah. Yeah, go to your y equals and click. Yeah, go to your y. There's nothing in it. Okay, then just wait. So we need to change our window so it fits the data. What's the lowest x?
3.
It's job satisfaction. It can go to 0 or to 10, it says. No, it says actually the scale's 1 to 10. So we're going to make our x min be 1 and our x max be 10. Then it says the productivity is a scale from 1 to 100. So we're going to make our y min be 1 and our y max be 100. And press graph.